Hi folks, today let's start solving some problems involving exponential equations. So without further ado, let's get started. Solve for x in the equation 3 raised to the 5x minus 7th power equals 4 to the 3 minus 2x power. So in this problem, usually you want to try and get a common base, but 3 and 4, there's no way for us to really get a common base. So this is where we have to rely upon laws of logarithms to help us out. So in order to get started, we begin with that problem. And in order to bring those exponents down to work with, we need to take a logarithm on both sides. So we'll take a natural log. It doesn't have to be a natural log. You could use log base 3, a log base 4, log base 10. But natural log tends to work well with the calculator. Same thing with a log base 10. So we'll choose that option here. So what that allows us to do is bring the 5x minus 7 out in front of that natural log on the left hand side and the 3 minus 2x out in front of the natural log on the right hand side. So we have that quantity 5x minus 7 times natural log of 3 equals 3 minus 2x, that quantity times the natural log of 4. Now just distribute the natural log of 3 to all the terms on the left-hand side and the natural log of 4 to all the terms on the right-hand side. And you have 5x natural log of 3 minus 7 natural log of 3 equals 3 natural log of 4 minus 2x natural log of 4. So in order to solve for x, you just need to group all the x terms on one side. So we'll get all those terms of the x on the left-hand side, so add 2x natural log of 4 to both sides, and that's where you get 5x natural log of 3 plus 2x natural log of 4. And then we have to add this 7 natural log of 3 to both sides, and so you'll have 5x natural log of 3 plus 2x natural log of 4 equals 3 natural log of 4 plus 7 natural log of 3. Now just solving, we're trying to solve for x. Notice x is in both terms on the left, so we can factor it out. So you get x times the quantity, 5 natural log of 3 plus 2 natural log of 4, and then that should equal 3 natural log of 4 plus 7 natural log of 3. So x times that quantity, we have 5 natural log of 3 plus 2 natural log of 4. Divide both sides by that 5 natural log of 3 plus 2 natural log of 4, and we get x equals 3 natural log of 4 plus 7 natural log of 3, all that's in the numerator, divided by the denominator is given by 5 natural log of 3 plus 2 natural log of 4, and we have our answer. If we wanted to, we could punch this in a calculator, but it doesn't say us to, and so this is an exact answer. Okay, so let's take a look at another problem, very similar. So solve for x in the equation 4 to the 3x minus 2 power equals 7 to the 10x plus 5 power. And we want to round our final answer 5 decimal places. So in looking at this, we can proceed by using those laws of logarithms once again. So that means we take the natural log of both sides, so you get natural log of 4 raised to the 3x minus 2 equals natural log of 7 raised to the 10x plus 5 power. And that allows us to bring down those exponents, so you have 3x minus 2. And once again, make sure to pay close attention to these parentheses. 3x minus 2, all of that is times the natural log of 4, not just the 2. So that's why we put the parentheses there. Same thing with the 10x plus 5, that's in parentheses, times that natural log of 7. Okay, so now moving from there, we distribute the natural log of 4 on the left-hand side and the natural log of 7 to all the terms on the right-hand side. So you get 3x natural log of 4 minus 2 times natural log of 4 equals 10x natural log of 7 plus 5 natural log of 7. And so now we want to try and group our x terms on one side and our constants on the other. So we'll first begin by subtracting both sides by 10x. We'll first begin by adding 2 natural log of 4 to both sides. And so that'll cancel out the 2 natural log of 4 on the left-hand side, and so then we have that. Now we'll subtract the 10x natural log of 7. Notice you could actually do this in one step, by the way. So you get 3x natural log of 4 minus 10x natural log of 7 equals 5 natural log of 7 plus 2 natural log of 4. Okay, so we have all our x terms on one side, and so what we do, we can factor out the x. This gives us x times the quantity 3 natural log of 4 minus 10 natural log of 7 equals 5 natural log of 7 plus 2 natural log of 4. So now all we need to do is just divide both sides by the terms times x. So divide by that 3 natural log of 4 minus 10 natural log of 7 on both sides, and we have x equals 5 natural log of 7 plus 2 natural log of 4. That's all in the numerator, divided by our 3 natural log of 4 minus 10 natural log of 7. Now, the problem is actually asking us to round 5 decimal places, so all we need to do now is just use a calculator. And the key to this is put parentheses around your numerator. So parentheses 5 ln 7 plus 2 ln 4. Close the parentheses. Hit the division symbol. Then you hit another parentheses to start the denominator. We want all the denominator in parentheses. So 3 ln 4 minus 10 ln 7. Close off those parentheses. And we get our final answer of negative 0.81712. So we can just use our calculator to get this decimal approximation, and obviously we have the full answer written to the left of that value. 5 natural log of 7 plus 2 natural log of 4 in the numerator, 3 natural log of 4 minus 10 natural log of 7 in the denominator. Okay, so let's take a look at another type of problem. Let's say we want to find the inverse of the one-to-one function f of x equals 10 raised to the 3x minus 8th power. So in this case, we got to recall, how do we find inverses? Well, there's a series of steps that we can kind of go through. The first step being replace f of x with y. So we can rewrite this as y equals 10 to the 3x minus 8. And then our main goal now is to try and solve for x. So with that, we can rewrite this just by properties of logarithms, the definition of the logarithm, in fact. You can rewrite this as log base 10 of y equals 3x minus 8. Okay, well, just simplifying that a little bit more, a couple ways. Log base 10, that's a common logarithm, so we'll call it log of y. And then we can add 8 to both sides, so we have log of y plus 8 equals 3x. And now just divide both sides by 3. So you get x equals log of y plus 8, all in the numerator, divided by 3. And then now we're ready for our final step to find the inverse function. And so all you need to do is you replace the x. Everywhere you see an x, you're just going to put that f inverse of x, and there should only be one spot because we solved for it. And then we're going to replace every y that we see with x then. So you get f inverse of x equals the log of x plus 8 divided by 3. Okay, similar problem. Find the inverse of the function. This will be a little bit nastier than usual. F of x equals 6 raised to the x minus 2, that quantity cubed, plus 7. All that's up in the exponent. And then minus 11 outside that exponential function there. So same process as we do with all the inverse functions. So we begin by replacing f of x with y. So you get y equals 6 raised to the x minus 2, the quantity cubed, plus 7 power, minus 11. Okay, so now next step, what we want to do after we have that y in there, we just solve for x. So first things first, we'll go y plus 11. So now we have everything on the right hand side is just a power of 6. So we can use those the definition of the logarithms. So this is just rewritten as log base 6 of y plus 11 equals, and then whatever's in the exponent. So the quantity x minus 2 cubed plus 7. Okay, well now we just need to solve for x, so we need to subtract the 7 from both sides, and that's how we get the log base 6 of y plus the quantity y plus 11 minus 7, and that equals x minus 2, that quantity cubed. How do we get rid of the cube? Well, we take the cube root of both sides. So when we take the cube root of both sides, you get the cube root of log base 6 of the quantity y plus 11 minus 7, and that equals x minus 2. And now we add 2 to both sides, and so we get x equals the cube root of log base 6 of the quantity y plus 11 minus 7. It's all underneath that cube root. And then we have a 2 on the outside of that cube root. And so for our final step, it's actually quite easy. We just replace x with f inverse of x. So we have an f inverse of x on our left-hand side, and replace a y with x. And so we get the f inverse of x equals the cube root of log base 6 of the quantity x plus 11 minus 7, all that's underneath the cube root there, and then plus 2 on the outside. So showing how we can solve for those inverse functions. Okay, last but certainly not least, find the inverse of the function f of x equals e to the 3 to the 5 to the x. So notice, since all these are raised to powers, there's not parentheses here. This isn't just multiplication of the exponents. It doesn't work that way. So it's a little bit different of a problem. This is nested exponential functions, so things get a little bit nastier here. But the process can be done the same. So first things first, we replace f of x with y. Now, moving forward from here, we want to solve for x. Notice x is at the top of that tower of exponents. So the way to get it down is we take the natural log of both sides. Take the natural log of both sides. Now what happens? Well, the natural log of the e, remember those things they essentially cancel, or they're inverses. If you look at the natural logarithm and the function natural logarithm of x and the function e to the x, those are inverses, so we're just left with what's up in the exponent essentially. So this becomes natural log of y equals 3 to the 5 to the x power. Okay, we're one step closer. So we can redo this process. Instead of natural log, so that's the log base e, recall, we can use a log base 3 with our next one. And that's exactly what we'll do. So we take a log base 3 of both sides. And so when we have that, notice you have the base of the logarithm and the exponential base on the right-hand side being the same. So those things kind of cancel. So you're left with 5 to the x on the right-hand side, and you have log base 3 of natural log of y. Now, how do we get rid of the 5 to solve for x? Well, we take a log base 5 of both sides. So this gives us x equals the log base 5 of the log base 3 of the natural log of y. And just recall that natural log is just the log base e once again. So without further ado, what do we have? Well, we get our final answer will be just by replacing the x with f inverse of x and the y with x. We get f inverse of x equals log base 5 of the log base 3 of the natural log of x. So this shows us how we can work with inverses of exponential functions and kind of use those logarithms hand in hand to solve these exponential equations and inverses.